Welcome to video 5.3c, a proof with parallel lines. So here's example 2. I'll mark up the diagram as we go. All right, so we're given angle 1 is congruent to angle 2. AB is congruent to FE. And AB is parallel to FE. Again, I will extend those. Sometimes I put double arrow ticks so you don't think it's an arrow for a line. All right, so that's what I'm given. I want to prove that AC is parallel to DF. So it gets a little bit confusing when there's multiple parallel lines. I will use a different color here. I'll use black. So what I'm trying to do is to prove that those two black lines are parallel. Okay, so what I'm going to do is, like I usually do, start with what I'm trying to prove and go backwards. So if I'm trying to prove two lines are parallel, there was those 7 theorems. There was those 2 kind of oddball ones at the end, but all the others involved congruence or supplementary with the transversals and the parallel lines. So it looks like to me these angles here would be involved in the parallel lines and a transversal. So that's what you want to look for. Angles that are involved in being parallel and with a transversal. This angle here and this angle here, they're involved in the parallel lines you're trying to prove, but they're not involved in any transversal. So that's some of the analysis you got to get used to. Okay, and these two lines, the next I want to kind of see what kind of angles they are, excuse me. They're on the outside, the exterior, and alternate, so they're alternate exterior angles. If I could get those angles to be congruent, proof over parallel lines. So now my real goal is to get that angle to be congruent to that angle. Now I have direction. How to get that angle to be congruent to that angle? Now I'm thinking of getting the triangles congruent. Okay, so now I'm shifting my focus back to chapter 3, getting triangles congruent. Again, I've got that side with that side. They gave me that angle with that angle. We've done this a million times. I'm taking the supplementary trick. So I will have an angle there and an angle there. They gave me this being parallel to this, and I do have a transversal here, so I think I will be able to get those angles congruent. They're on the inside and alternating side, so those would be alternate interior angles. So now I have a plan for what I'm trying to do. I'm going to be using ASA to get the triangles, and then I'll take the proof home from there. So now I've got some clear direction. Now and only now do I start writing down my proof. Okay, so getting the triangles by ASA, I will start with this statement right here. So angle 1 is congruent to angle 2. That was given. Now I'm going to say angle 1 is supplementary to, I got to use 3 letters, CAB. And angle 2 is supplementary to angle DFE. If angles form a line, then they're supplementary. You could say straight angle, but line's quicker for me to say. Okay, so now I've got angles 1 and 2 congruent, and I get the supplementary. So now I'm going to have these 2 angles being congruent. So angle CAB is congruent to angle DFE. This is way back in chapter 1. If angles are supplementary to congruent angles, then they're congruent. If angles supplementary to congruent angles, then congruent. And that is the A in ASA. Okay, then I'm going to just list the sides. They gave me that right there. AB is congruent to FE. That was given. Then I'm going to use what they told me here in green. They told me those green things were parallel. Again, I'll extend my transversal too. So again, it's kind of hard for students when the parallel lines are not horizontal, but you got to get used to it. So this angle here and this angle here, they're on the interior and they're on alternating sides of that transversal. Okay, so if those lines are parallel, I'll get those alternate interior angles to be congruent, and you got to make sure you label those correctly. So I better start with saying that the lines are parallel. So AB is parallel to FE. That was given. And then based off of that, I'm going to get those angles I was talking about. And you could just use one letter. There's no angle confusion. So I could say angle B is congruent to angle E. That's going to be my angle part of ASA. And I'll say if lines parallel, then alternate interior angles are congruent. Okay, now I'm going to get those triangles congruent. I ultimately care about that angle and that angle. So I'll say triangle ABC. I got to be careful now. If I start with A, I'm going to start with F. AB, so FED. And that would be by ASA. And then, once I get those triangles, I could get those angles that I'm ultimately concerned about. So I can say angle C is congruent to angle D. Notice last letter, CPCTC. And now, once I've got alternate exterior angles congruent, gosh darn it, the lines are parallel. So AC is parallel to DF if alternate exterior angles congruent, then lines are parallel. So there you have it, how to do a proof involving parallel lines really going in both directions.